So for 1,000 years, I mean literally a millennium, the greatest medical minds on Earth just thought your brain was this giant wet lump that secreted phlegm.
Yeah, which is completely wild to think about today.
Right. Because today we know it's this incredibly complex master control center holding, 86 billion perfectly mapped neurons. But here is the crazy part. The medical vocabulary your doctor uses right now is still kind of trapped somewhere between those two totally different realities.
It really is. It's like we're speaking two different languages at once.
Exactly. Like if you open up a beginner's medical dictionary and look up the root words encephalo and cerebro, both of them are basically translated simply as just brain. It seems like a perfectly harmless shorthand, right? Just a way to make it easier for new students.
Right, but that exact oversimplification, that's where widespread medical confusion actually starts.
Which is our mission for this deep dive into the source material. We're going to unpack why these two roots are absolutely not interchangeable. We're exploring the bizarre history of how they were defined, which involves ancient animal dissections and rogue Renaissance grave robbing.
Always a fun combination.
Right. And most importantly, we're going to reveal why understanding this distinction isn't just some, vocabulary exercise for med students. Knowing the difference between the whole and the parts can literally change the trajectory of patient care for you or your family.
Oh, absolutely. The stakes are incredibly high, especially in emergency and critical care. You really have to know the actual physical difference in the anatomy being referenced.
Well, let me jump in here with some skepticism, though. Because if both terms essentially translate to brain for the average person on the street, aren't we just splitting anatomical hairs?
Oh, get why you think that.
Like, if a doctor uses one instead of the other, what is the actual tangible difference we're looking at?
Well, it really comes down to the part versus the whole. So the root encephalo refers to the entire brain exactly as it sits inside the cranium.
The whole package.
The complete biological package, yeah. We're talking about the cerebrum, the cerebellum, and the brainstem, which, itself includes the midbrain, the pons, and the medulla oblongata.
Okay, so it's comprehensive.
Exactly. When a clinician uses a word built on encephalo, they are signaling that the brain as a whole organ system is involved. They are purposefully not isolating one specific region.
So encephalo is basically the umbrella term for absolutely everything inside the skull.
Yes. Now, contrast that with cerebro, which refers specifically and only to the cerebrum.
And that's the big part, right?
Right. That is the large, wrinkled, two-hemisphere mass that sits on top of everything else. By volume, the cerebrum is the biggest single structure in the skull. In an adult human, it makes up roughly 80 to 85% of the total brain mass.
Wow, so it's huge.
It takes up most of the visual real estate, but, and this is the crucial distinction here, it is still only one part of the system.
So conflating the two would be like popping the hood of a car, pointing at the engine block and calling it the entire vehicle.
That's a great way to look at it.
I mean, the engine is massive. It does a lot of the highly visible work. But if you just completely ignore the transmission and the fuel lines and the alternator, well, the car isn't going anywhere.
That analogy hits the nail right on the head. And unfortunately, our everyday English really sabotages our understanding here. People use the word cerebral constantly to mean just, of the brain in general.
Oh, we hear it all the time. Someone reads a really dense philosophical book, and we say, oh, she's a very cerebral person, meaning she's an intellectual.
Exactly.
We aren't actively trying to make a highly specific anatomical claim about her forebrain.
Right. But in medicine, cerebral strictly means involving the cerebrum. Full stop. To understand how we ended up with two different words for the brain and why they stubbornly remain separate in clinical charts, we kind of have to look at the history of how the brain was mapped in the first place.
Well, let's travel back to a time when our understanding of human anatomy was, frankly, mostly guesswork.
A lot of guesswork, yeah, driven by very strict legal limitations. So let's start with the Greek origin of encephalo. It comes from the ancient word encephalos, which literally translates to in the head. En means in, and kephale means head.
Very literal. I like it.
The physician who really cemented this term was Galen of Pergamon, who was arguably the most influential physician of antiquity. He was practicing around the 2nd century CE.
Okay.
And Galen made this massive conceptual leap. He successfully argued against rival schools of thought that believed the heart was the center of human thought. Galen actually proved that the brain was the actual seat of sensation and voluntary movement.
But this is the wild part. He proved this without ever actually looking at a human brain,
Right.
right? Because Roman law strictly forbade human dissection at the time.
He had to rely entirely on animal models. So he extensively dissected pigs and monkeys, mapping their nervous systems, and then just, well, applying those findings directly to humans.
Just assuming it was a one-to-one match.
Pretty much. But because ancient technology was so limited and animal brains obviously differ from human brains, ancient and medieval writers didn't really conceptualize the brain as a machine with highly specialized, distinct parts.
They just saw it as one giant, mysterious blob.
Exactly. They thought this blob either secreted phlegm down into the nose, or they thought it served as this hollow housing unit for quote-unquote animal spirits to flow through the nerve.
Animal spirits, wow.
Yeah, they had no real concept of the distinct cerebral and cerebellar regions we recognize today. So Galen's Greek terminology, this word for the whole lump in the head, it survived intact in medical writing for over 1,000 years.
Okay, so Galen gives us the Greek term because he couldn't legally dissect humans. But eventually someone breaks that law and looks closer, which means the language had to adapt. How do we get to the Latin shift with cerebro?
That decisive, really modernizing moment arrives in the Renaissance. In 1543, Andreas Vesalius published a revolutionary anatomical atlas called De Humani Corporis Fabrica.
And Vesalius did the unthinkable, right?
He did. He totally abandoned Galen's centuries-old animal models and dissected actual human cadavers, often going out and acquiring bodies from the gallows.
So he finally looked inside the actual human skull. And what he saw wasn't just a uniform blob of phlegm.
No, not at all. He saw distinct, highly differentiated structures. He vividly illustrated the massive human cerebrum on top and the distinct cerebellum, which literally translates from Latin as little brain tucked underneath at the back of the head.
Right.
And because Vesalius was writing in the scientific language of his day, he used Latin nomenclature to map these specific parts.
I mean, it feels a bit chaotic to mix two completely dead languages just because of who got to the human cadaver first.
It does seem messy, I'll give you that. But it created a highly systematic, hybrid vocabulary that modern medicine relies on today. We kept the Greek combining form encephalo to represent the entire historical lump in the head.
The whole system.
Right. And we paired it with the Latin combining form cerebro to describe the specific major anatomical part that Vesalius mapped. You actually see this Greek for the whole, Latin for the parts pattern all over medicine.
Like with the kidneys, right?
Exactly. We use the Greek nephros for broader clinical concepts regarding the kidney, like nephrology, but the Latin renes gives us the specific anatomical adjective renal.
So we are essentially speaking this layered language of human discovery. Let's pivot from the ancient world to the modern hospital, because this size and scope difference dictates the actual diagnoses you hear from a doctor today.
Absolutely, it does.
If you strip away the jargon, what is the underlying logic for when a doctor uses one route over the other?
The underlying logic is purely about territory. A clinician chooses the route based entirely on how much of the brain is involved in the disease process. So consider the difference between encephalitis and a cerebral stroke.
Okay, let's break that down. Encephalitis has the Greek root for the whole brain, plus hematitis for inflammation.
Right. Take herpes simplex encephalitis, for example, which is the most common cause of sporadic fatal viral encephalitis in the U.S. When that virus breaches the blood-brain barrier, it does not respect anatomical borders.
It just goes everywhere.
Pretty much. It might inflame the temporal lobes, spread down into the brainstem, and hit the cerebellum. The inflammation is diffuse. It involves the whole organ system.
So it's like a house fire. The fire doesn't care if it's in the kitchen or the living room. The entire structure is burning.
That's a brilliant way to picture it. Now, contrast that diffuse fire with a cerebrovascular accident, which is the clinical term for a stroke. The prefix, cerebro, is doing highly specific work there.
Because it's localized.
Yes. The most common type of ischemic stroke involves a blood clot blocking the middle cerebral artery, or the MCA.
Wait, so when my aunt had a stroke, and the doctor said it was a cerebrovascular event, they weren't just using $10 words to sound authoritative, they were explicitly ruling out the rest of the package.
Yes, they were telling you exactly which plumbing failed. The middle cerebral artery supplies blood almost exclusively to the cerebral hemispheres. It does not feed the cerebellum, and it does not feed the brainstem.
Okay.
So when that specific artery is blocked, the doctor knows the tissue death is localized to the cerebrum.
Mm.
And because we know what the cerebrum does, the doctor knows exactly what functions are at risk. Usually things like speech, vision, or motor control on one side of the body.
It's a localized plumbing issue, not a whole house fire.
Yeah.
That makes perfect sense. And this distinction is also vital when we look at developmental conditions like anencephaly.
Right. Anencephaly is a devastating congenital condition. Let's just look at the construction of the word for a second.
Yeah.
It means without. Encephal means the whole brain system, and encephy makes it a noun.
So literally without brainness.
Exactly. And the choice of encephalo here is incredibly deliberate.
Because the whole system is affected.
Right. During early embryonic development, there is a structure called the neural tube. You can kind of think of it like a biological zipper that closes up to form the early central nervous system.
Okay, a zipper.
In encephaly, that neural tube fails to close completely at the top, or cranial end. Because of this, the fetus develops without a forebrain, without a cerebrum, and often without the cranial bone vault entirely.
Oh, wow. So the entire scope of the organ system is catastrophically compromised.
Yes, but understanding the exact mechanism of how that neural tube zips up led to a truly astonishing public health victory.
Because we learned that a specific nutrient acts like basically molecular grease for that zipper.
Folic acid. It is absolutely crucial for DNA synthesis and cell division during those critical early weeks of pregnancy when the neural tube is closing. So in 1998, the United States mandated that enriched grain products be fortified with folic acid.
And the results were immediate and staggering. I mean, the CDC documented a drop of roughly 35% in neural tube defects overall.
It's incredible.
It is a massive public health win born directly from understanding the mechanical development of the entire encephalon.
And we've established that the cerebrum is the massive star of the show by volume, 85% of the total mass.
Mm.
But this is where our intuition really tricks us.
How so?
Well, in biology, volume does not always equal processing power.
Right. Because our natural assumption is that since the cerebrum is the biggest engine, it must produce the most horsepower. Like it must have the most neurons doing the heavy lifting.
But the microscopic reality completely destroys that assumption.
I love this part. To understand why, we have to look at the fascinating work of this Brazilian neuroscientist, Susana Herculano Husel.
Yes, around 2009, she realized that previous estimates of how many cells were in the brain were, well, basically educated guesses.
Just throwing numbers at the wall.
Exactly. So she developed a method using something called an isotropic fractionator.
And I read about this in the sources, and it is just beautifully mad science. Instead of trying to slice the brain paper thin and count cells under a microscope, which is like trying to count the trees in a massive, dense forest, she essentially created a brain soup.
She did. I know it sounds crazy, but the isotropic fractionator dissolves the cell membranes but leaves the cell nuclei completely intact.
Okay.
So by turning a specific brain region into a uniform, homogeneous liquid, she could stain the nuclei and count them perfectly. It eliminated all the irregular folding and density variations that made counting impossible before.
So what actually happened when she counted the nuclei in this soup?
She found that the average human brain contains roughly 86 billion neurons total.
86 billion.
But the distribution is the true shock here. The tiny cerebellum vesalius's quote-unquote little brain that makes up just 10% of the volume holds an astonishing 69 billion of those neurons.
Wait, let me make sure I'm doing that math correctly. Out of 86 billion total neurons, 69 billion are crammed into the cerebellum.
Yes. Roughly 80% of all the neurons in your entire head are densely packed into that tiny 10% of volume at the base of your skull.
What about the massive cerebrum, the giant wrinkled structure we always picture when someone says brain?
Despite taking up 85% of the space, the cerebrum holds only about 16 to 19 billion neurons.
That completely flips our understanding of brain architecture. The little brain is doing the vast majority of the neuron firing work. It is just infinitely more dense.
It is. The cerebellum coordinates movement, balance, and fine motor skills, which require incredibly complex, rapid-fire calculations. Size and neuron count are entirely different metrics.
Which really highlights the flaw in our casual language.
How do you mean?
Well, when we call the deep thinker very cerebral, we're using an anatomical term that completely ignores the structure actually doing 80% of the neuronal work. We are giving all the credit to the bulky manager and ignoring the densely packed engineering department doing the actual processing.
That's a perfect analogy. But it's not just everyday language that gets it wrong. Even within the highly rigorous medical community, there are deeply entrenched terms that flat out contradict modern anatomy.
Because medicine is a human endeavor, sometimes history and early theories just get permanently baked into the vocabulary, creating what we call historical fossils.
Exactly. And the most glaring example of this historical fossilizing is cerebral palsy.
Let's trace this fossil back. The condition was first clinically described in the 1860s by an English orthopedic surgeon named William John Little,
Right.
and he observed children with rigid, spastic muscles, and he concluded that the cause was oxygen deprivation asphyxia during a difficult birth. For decades, it was simply known as Litter's disease.
But in 1897, a neurologist stepped in and argued that Little's birth asphyxia theory was physically impossible based on the symptoms, and that neurologist was actually Sigmund Freud.
Wait, Freud, before he became the father of psychoanalysis, he was doing hard neurological research.
He was, yeah.
So why did Freud think Little was wrong?
Freud noticed that the children exhibited symptoms that pointed to highly complex structural development problems, not just a one-time lack of oxygen. The symptoms were too varied. Some children had spasticity, others had involuntary writhing movements.
So it wasn't a simple injury.
No, Freud proposed that the brain was fundamentally developing incorrectly before birth.
But the medical establishment was completely locked into Little's theory. I mean, they ignored Freud's monograph for nearly a century.
They really did. It wasn't until large epidemiological studies in the 1980s that obstetricians and neurologists finally admitted Freud was actually right.
Better late than never, I guess.
True. Today, we know that birth asphyxia accounts for a tiny fraction, perhaps 10%, of cerebral palsy cases. The vast majority stem from prenatal factors, genetic mutations, and prematurity.
Which means the term cerebral palsy is a massive historical misnomer.
Or two fronts, yes.
Right, because not only is it rarely caused by the birth trauma it was originally named for, but anatomically, the movement disorders aren't strictly localized to the cerebrum.
Exactly. The pathology heavily involves the cerebellum, the basal ganglia, which is basically the brain's deep movement control room, and the white matter tracts, which are the insulated cables connecting different brain departments.
So it's a total fossil. We just retain the name cerebral palsy purely for historical continuity, so patients and doctors know what condition they are discussing. But neurologically, the name itself is structurally inaccurate.
It is.
Are there other examples where history accidentally led us astray, or perhaps where bad science accidentally pointed us in the right direction?
Oh, definitely. A really fascinating example of bad science pointing us in the right direction is phrenology in the early 1800s.
Oh, the skull bumps.
Right. Franz Joseph Gall promoted the idea that specific human traits like aggression, wit, or combativeness were located in specific regions of the cerebral cortex, and you could measure them by feeling the bumps on a person's skull.
Which is pure pseudoscience. The skull bumps have nothing to do with brain function.
Complete pseudoscience. But Gall's underlying premise, that the cerebrum is compartmentalized into specific functional zones, well, that accidentally anticipated the very real, scientifically proven concept of cerebral localization.
So instead of just talking about the timeline of how that was proven, let's talk about the famous case that actually proved it. The story of a patient known to medical history simply as Pan.
Such a sad but important case. In the 1860s, a French physician named Paul Broca treated a man who had lost nearly all ability to speak. He could understand language perfectly well, but the only syllable he could articulate was the word tan.
So he had his full intellect, but his speech machinery was just broken.
Right. When the patient died, Broca examined his brain and found a highly specific localized lesion in the left frontal region of the cerebral cortex. This wasn't a diffuse whole brain problem. It was localized damage to a specific neighborhood.
And that proved that expressive speech lived in that exact spot, which is now known as Broca's area.
Exactly. This definitively proved that the cerebrum is highly specialized.
So Gall's phrenology was dead wrong about the bumps, but Broca's patient proved the core idea. The brain is not a uniform blob. But, if we know all of this today, if we can literally count neurons and pinpoint speech centers, are we still making terminology mistakes in modern hospitals right now?
Oh, we absolutely are. If you look at modern hospital charts, particularly in the ICU, you will see neurologists constantly fighting against the overuse of the term encephalopathy.
I see that term constantly. toxic metabolic encephalopathy, hepatic encephalopathy. I mean, it sounds incredibly serious.
It is serious, but it's often used as a lazy catch-all label. When a clinician writes encephalopathy, they are essentially using the Greek root to just say, well, the whole brain is functioning poorly.
Right.
Maybe the patient is confused, agitated, or unresponsive. The danger is that slapping a broad, diffuse label on the chart treats the brain like a black box. It allows clinicians to document the confusion without actually committing to finding the specific underlying mechanism.
And if you stop looking for the mechanism, you might miss something entirely treatable.
Precisely. If a chart just says encephalopathy, the medical team might stop looking for precise issues like drug-induced delirium or an underlying infection. The vague language actively obscures the pathway to treatment.
Which brings us to the real-world stakes for anyone listening. Getting these roots right is a critical piece of medical literacy.
It really is.
Because if a newborn is diagnosed with HIE, hypoxic ischemic encephalopathy, the parents need to understand that the encephal root means it is a diffuse whole brain injury. The entire system was starved of oxygen.
Right, and that dictates intense whole-body treatments like therapeutic cooling to slow down the cellular damage everywhere at once.
Inversely, if a family member suffers a cerebral infarct, the language tells you immediately that the damage is localized strictly to the cerebrum.
Yes. You know, to look for localized symptoms like one-sided facial drooping or slurred speech, if they had suffered a cerebellar stroke in the little brain, the symptoms will be entirely different, like severe dizziness, inability to walk, or profound nausea.
The anatomy dictates the vocabulary, and the vocabulary dictates the outcome.
Yeah.
Which leaves us with a somewhat unsettling thought to wrap up this deep dive.
Oh, absolutely.
We saw how Freud's entirely accurate, mechanistically sound theory about cerebral palsy was ignored for almost a century because the medical establishment was blinded by accepted history. They trusted the old terminology more than the new evidence.
He really did.
So as you navigate modern medicine, especially when you see vague, debated labels like encephalopathy being thrown around the ICU, it makes you wonder, what other historical fossils are hiding in plain sight in our medical charts right now, just waiting for the science of tomorrow to finally correct them?